Well, okay, so being kind of smart about this algebra, you could get kind of lost in this, but if we recognize that, well, distribute this negative, and we get x minus h minus q, keeping the x minus h kind of together, and again here, thinking of this as x minus h plus q, now we can square both sides. And if we square both sides, we're going to get x minus h minus q squared plus y minus k squared equals x minus h squared plus 2q x minus h plus q squared. And again, this can be squared. So this is really like x minus h squared minus 2q x minus h plus q squared plus y minus k squared equals x minus h squared plus 2q x minus h plus q squared. And really this is just the exact same proof as before. It's just that if you look back at what we did on the previous pages, except everything's canceling everywhere where there was an x squared, there's now an x minus h squared. And actually, after all the sort of dust clears, all we end up with is y minus k squared equals 4q x minus h. In other words, the equation of a parabola, which is horizontal and opening right, and in which the vertex is at hk, instead of that being 0, 0, it's exactly like the old equation, which is y squared equals 4qh. This was when the vertex was at 0, 0, but this is when the vertex is at h comma k. And it does exactly kind of what you would expect. The x-coordinate has been shifted over by h, the y-coordinate has been shifted over by k. Alright, and since this kind of happens over and over again, this is the last time that we're going to do this. For the other conics, we won't bother redoing the whole derivation if the center moves, because if the center moves, everything just moves. But in this case, the proof wasn't so hard, so I think it was worth doing. Alright, let's just go to page 6, and we're going to do these, on the top of page 6 is just kind of like a summary of all the 4 cases. So let's just do these last 2 problems on page 6, and then we'll be done. All right. Let's see if I can get the whole frame in. Yeah, good. Just erase this, and you can just start right now. Alright, let's see. Sure. Alright, so we have negative 16x plus y squared plus 12y. Here we have 4x. Okay. And in both cases, I have an equation, and what I would like is, to put the equation in standard form, make a graph, and give all the sort of facts about this thing. Okay, let's go. Superficially, I see that the quadratic term here is a y, and the linear term here is an x. And so I should be thinking already that I want this kind of in the form of y squared equals 4qx, or possibly negative of that. All right, so that being the goal then, let's get all the y terms on one side, and let's get all the x and constant terms over to the other side. So this is 16x plus 12. And I mean, yeah, that's really kind of all there is. Now I want to complete the square, and therefore this needs to be a 36, so I add a 36 to the left, and I add a 36 to the right. And thus, this is y plus 6 squared, and over here I get 16x plus 48, but really that's like 16x plus 3. Alright, and that's really just it. I guess if you wanted to, maybe it's a good habit to get into of writing this as y plus 6 squared equals... No, I think I just leave it like that. Alright, good. So what do I know about this? If this is a y squared equals 4qx type parabola, then it means it's opening right. So this opens right, and also, where is the vertex? Well, the vertex, instead of being at the origin, is at -3, -6. And also, Q is 4, just because. Alright, and that's kind of really everything I need to know to make a graph of this thing. Let's do it. Here's my graph. I go over to -3, -6, 3, 4, 5, 6. Bump. -3, -6 is my vertex. Where is my focus? Well, if Q is 4 and it's opening right, then my focus is 4 that way. So my focus will be here at 1, -6. Where's the directrix? It's going to be 4 to the other side. So it's going to be 3, 4, 5, 6, 7. So my directrix will be the line x equals -7. And the parabola itself is going to be, okay, not trying particularly hard to make this accurate or anything. It's going to look something like that. Opening right, pretty good. Okay, anything else we were supposed to do? Directrix, focus, vertex, I think we're good. Okay, let's do one more. Here, okay, this is kind of a silly problem. I guess I could just divide by 4 right off the bat. So I have x squared plus 6x plus 16y minus 7. And then that makes it kind of silly, I guess, because this is, I see that the quadratic term is x, the linear term is y, so this is going to be in the form x squared equals 4qy. Okay, so again, x squared plus 6x, get the x terms over to one side, and subtract the other terms over to the other side. Alright, well now I'm going to complete the square with respect to the quadratic term, so I need to add 9 here, and I also add 9 here. So this gives me x plus 3 squared equals -16y, but then plus 16. And so really, I'm not done until I write it as -16y minus 1. Woo! Alright, good. Well, yeah, what kind of a parabola is this? In fact, it turns out to be an x squared equals -4qy type problem. So this parabola is going to open down, right? Because it's just kind of like this is basically like y equals x squared, but with a negative. So this opens down, and what else? It's going to have a vertex at, well, the x-coordinate moves to the left 3, the y-coordinate moves up 1, so my vertex will be at -3, 1. Q is again 4, just because. And maybe that's it. Alright, let's draw it. Okay, vertex -3, 1, boom. What is my, where is my focus? Well, if my parabola is opening down, then that means that my focus must be down somewhere. So down 4. So it will be at -3, -3. And where is my directrix? My directrix is going to be above. So that will be 4 above -3, 1. So 1, 2, 3, 4, 5. So So this is the line y equals 5. That is the directrix, and the parabola itself will be opening down like so. All right, that's pretty good. And that's kind of everything you need to know about parabolas, I guess. A little formulaic, but there it is. Okay, goodbye, class.